Hey everybody, today we're going to work on surface area and volume lesson number 3, and we are basically going to combine all of the different volume formulas into one lesson. Now volume is just how much stuff you can put inside of something. It's a three-dimensional measurement. How much space is on the inside of a figure. So this isn't going to be like it was before, where we had to lay things out, make a net or whatever it was that we did for surface area, depending on the figure. Now we're going to see how much fits inside of a figure. Now, what I have right here is the Ohio State Test reference sheet. It's what you are given when you take the end of course exam for geometry. Now, the main reason why I don't spend a lot of time doing volume is because what we really need is practice on how to execute the formulas. You are given the formulas. We have all of the different volume formulas. So we don't really need to memorize them if we want to be successful on the end of course exam. We just have to know how to use them. So that's what we're actually going to practice here. First, we're just going to write down the formulas as you see them. So for a prism, the volume of a general prism, that means any prism, according to the formula sheet, is big B times H. Now, when we start talking about big B, you should know that big B is the area of the base. So that's a big key here as we go. Big B means the area of the base. Okay. Now you're also going to see big B in the formula for a pyramid. There's one difference. In the pyramid formula, it's 1/3 in front. As in, if you had a prism and you had a pyramid and they had the same height and the same base, the pyramid would only hold 1/3 as much stuff. Now you're going to notice this 1/3 pattern. It's going to continue, and it's going to continue with cylinders and cones. So for a cylinder, the volume is pi r squared times the height. Now, if you're wondering why is it pi r squared, well, you know that pi r squared is just the area of a circle. So when you read something like pi and then r squared, it shouldn't really surprise you a whole lot because we know that pi r squared is the area of a circle. So it really is just the area of the circle multiplied by the height when you put it all together. Now, if you look at the cone, you will notice, and I'll put this up here in a second, the cone is the exact same formula, but with a 1/3 in front of it. So it's still pi r squared times the height. The only difference is, just like for a pyramid, in case you haven't picked up on it yet, a cone will only fit 1/3 as much stuff. Now, if this was not a video, if this was me in a classroom, this is usually where I get out a cone and I get out a cylinder and I do the demonstration. The cone only holds 1/3 as much stuff. You could fill the cone 3 times and you would end up filling the cylinder. It does work. It works pretty much exactly. It's kind of a cool demo, but like I said, this is a video. This isn't going to be that easy to do. Now, the one formula that is going to be different, and now we're actually also talking about a figure that we haven't done up to this point, is a sphere. Now, if you look on the formula sheet, the volume of a sphere is 4/3 pi r cubed. Okay, so let's put a little 4/3 in here. And then we are using a cube here because we are talking about a 3-dimensional measurement. Now, the reason we haven't done anything with a sphere to this point is because the surface area of a sphere is something that can't really be laid out with a net. It doesn't really work that easily here. So that doesn't mean a sphere doesn't have a surface area. It just means we haven't done it yet. Now, it turns out the surface area formula for a sphere, so we're going to treat this like a bonus formula right here. The surface area of a sphere is actually just 4 pi r squared. So it's exactly the same as the volume, only you take out the first 3, and then you turn the exponent from a 3 to a 2. So it's not too bad. And we can practice that here once. We'll do a little problem at the end with it. But that's how it works. So again, we don't really need to work on memorizing the formulas right this second. We just need to practice them. So let's talk about how they are similar. In a prism or a cylinder, you multiply the area of the base by the height. Area of the base is listed as big B. And in a cylinder, the area of the base would be pi r squared because the base is a circle. Cones and pyramids are similar. You do the same thing. The only difference is you only want 1/3 of that amount. So hopefully we can find some patterns as we go. All right. Now, what you're going to find out as you go through this is that you are going to probably like volume more than you like surface area because you don't have to draw out a net. You don't have to break it down piece by piece. You just have to do what it tells you to do. The biggest key is identifying what the base actually is. So if you look at this first figure, this right here is a triangular prism, and the base is this triangle. This triangle has a 12 by 9 dimension right here. The area of this triangle right here is 1/2 base times height. So when we're talking about that big B, we're talking about the area of that triangle. So 1/2 times 12 times 9, which would be 54. So the volume of this will be 54, because that is big B, that is the highlighted area, times the height of the prism, which is 5. 54 times 5, throw it in your calculator, and you get 270. And remember, volume, we're talking about how much stuff we can fit inside of it, so it's actually cubic inches. So now we are introducing that exponent of 3 as we go and as we are making our labels. So again, these figures should look familiar, but now today, instead of doing surface area, we are doing volume, and we are already done with the first one. So now we're rolling. Let's look at the second one. It's also a prism, but the base is a pentagon. So we need to figure out the area of the base. Now, the formula for a pentagon or any regular polygon is going to be 1/2 times the apothem times the perimeter. Remember, a regular polygon is 1/2 AP. All right, now they gave you the apothem. It wasn't too scary. The apothem was 3.4. The perimeter of this thing would be every side put together, 5, 10, 15, 20, 25. And so if we're going to do the volume, we're going to do the area of the base, which if you take that number and multiply it all out, you're going to get 42.5. And then you're going to multiply by the height, which is 11. And you find out that the volume is 42.5 times 11, which is 467.5. And again, here we go with changing our unit. It is a volume, so we are going to go cubic centimeters. So again, if I'm losing people here, I'll just throw a calculator up there. 42.5 times 11, 467.5 centimeters cubed. So you do the area of whatever the base is times the height. All right. Now this next figure is a cylinder. So for this one, when you do the volume, it's going to be pi r squared times the height. Now, if you want to know what's going on here, think of this as a hockey puck. You need to knock it over. Okay, you need to knock over the hockey puck if you want to understand what's going on. The height is not 10. The height is 2. Okay. Now, if the diameter is 10, that means the radius would be half that amount, which would be 5. So when you are going through the cylinder formula and you are plugging things in, you have to use 5 for the radius, and you have to use 2 for the height. 5 squared is 25. 25 times 2 is 50. So in this particular case, the volume is going to be 50 pi centimeters cubed. Now, sometimes you're going to see a teacher or a test or a quiz that wants it rounded to 2 decimal places. In that case, you could just do 50 times pi, and you would get 157.08 cubic centimeters, or centimeters cubed. Either answer is correct. There's not really one answer that's more correct than the other. The exact answer is 50 pi. The answer rounded to 2 decimals would be 157.08 centimeters cubed. All right, pause this if you need another second to write it down, but we are going to move on. Now, in case you forgot, the formula for the volume of a cone is exactly the same as the volume for a cylinder. The only difference is there is a 1/3, because the cone will hold 1/3 as much stuff as a cylinder that has the same height and the same base. This time they gave you the radius, so you don't have to cut that number in half. All you have to do is work your way through it. Now, in this case, what a lot of kids forget to do, they get their 36 times 8 here, but then they forget to take 1/3 of that amount. So make sure when you go through this, you do 1/3 times 36 times 8. Now, I left off the pi, so I'm going to put it back here at the end, and I'm just going to say that my answer is 96 pi cubic feet. If you are told to round, then you could just do 96 times pi, and you could take the decimal, and you would get 301.59 cubic feet instead. These mean the same thing. The one written in terms of pi is more accurate. That is the exact answer. However, if you are told to round to 2 decimal places, use the second one. So again, you've got a couple different answers. They are both correct. It just depends on what you are looking for. All right, we go on to the pyramid, and the pyramid here is going to be just like it was for the prism. The only difference is we want 1/3 of that amount. The base of the pyramid is actually just an 8x8 square. Not a big deal. An 8x8 square would have an area of 64, and then the height was 3. Now, normally I would get a calculator out at this point, but I don't know if you noticed this, but 1/3 of 3 is just 1. When you take 1/3 of 3, you just get 1. So in reality, the 1/3 and the 3 cancel each other out, which means the final answer is just 64 cubic inches. That was it. There was nothing else to it because the 1/3 and the 3 canceled each other out. All right, so now let's get our first look at the sphere before we quit here. The volume of a sphere is 4/3 pi r cubed. So all we're going to do, the beauty of a sphere is that all you have to do is plug in one number. Okay. Now, what you end up getting here, if you were to do 5 cubed, you would get 125. times 4 would be 500. So if you wanted the exact answer, then you would have to write 500 over 3. And the reason I didn't do that on the calculator is because it comes out to a repeated decimal, and I figured I didn't want to scare anyone away with it. 500 pi over 3 centimeters cubed. So again, 5 cubed is 125, and 125 times 4 is 500, so it would be 500 over 3. Now, that doesn't look really pretty to some people. They don't like having fractions and pi together and all that. So I just want to do it on the calculator, round it as well. If you did 500 divided by 3 and then multiplied that number times pi, you would get 523.60 centimeters cubed. So again, both of these are mathematically correct. Now, I want to throw one thing here. I want you to put it in the margin of your paper. Remember, we have not done surface area of a sphere yet. So I want to throw that one in there as a bonus. It's not really a bonus. It's something you need, but we haven't talked about it yet because you can't really lay out a sphere using a net. So if you look on the top of your paper, surface area of a sphere is 4 pi r squared. So it's a similar formula, just with a couple little teeny differences. So if you are ever told to do the surface area of a sphere, it's not a big deal. It's the same idea as what we just talked about. You only have to plug in one number. That's why I want to make sure we go over it, even though we haven't done it to this point. 5 squared is 25. 25 times 4 is 100. So if they would have asked you for surface area, you would have just had 100 pi centimeters squared. Now again, surface area is squared. Volume is cubed. If you had multiplied the pi into it, you would have gotten 314.16 centimeters squared. Again, they are both good answers. It just comes down to what you want. All right, I hope this helps. Maybe that bonus sphere problem will help you out. They usually come up on ACTs, SATs, that sort of thing. So be ready for those, and we will see you next time.